This is my AP Calc AB final project. My first topic is velocity, speed, and acceleration. Velocity is the instantaneous rate of change, and it can be negative. Speed is the absolute value of velocity, and since it's the absolute value, this means it cannot be negative. It has to be positive. Acceleration is the instantaneous rate of change of a velocity function. This is where velocity is either increasing or decreasing. Information to know: when velocity is positive and acceleration is positive, the particle is speeding up. When velocity is positive and acceleration is negative, it's slowing down. When velocity is negative and acceleration is positive, it's speeding up. And when velocity is negative and acceleration is negative, it's slowing down. Also, position is the original function, s of t. Velocity is the derivative of that function, so the first derivative of x of t, or velocity. Acceleration is the second derivative of the position, so the second derivative of x of t, or it's the first derivative of velocity. A real-world example is speeding tickets. So how speeding tickets work is a radar or camera determines the position of the car in regard to time, and they use this position in order to create a position function. And we learned earlier that a position function is the first function. Next, the machine takes the derivative of the position function, and this derivative is known as the velocity. The speed is determined from the velocity function. So the speed is equal to velocity, so that is determined. And the police uses information to determine if a vehicle is going over the speed limit and by how many miles per hour. A career that uses velocity, speed, and acceleration is aerospace engineering. Aerospace engineer uses or designs missiles, aircrafts, and spaceships and satellites. And they also create propulsion systems and evaluate the aerodynamics of aircrafts. They use derivatives to determine velocity and speed for analysis and troubleshooting their designs. They also use derivatives to analyze aerodynamic performance. So they basically use derivatives to make sure their products work and their spaceships and aircrafts fly. The second topic I'm doing is Newton's law of heating and cooling. Newton's law of heating and cooling is a differential equation that shows the rate at which an object heats or cools in its proportion to the difference between the object's temperature of the surrounding environment. So it's basically like it takes what an object's heat is at one time and its heat at like 10 minutes later, and then it also factors in the temperature of the environment that this object is in. A constant of integration is the constant added when integrating. The value determines which of a family of antiderivatives is the particular solution to a differential equation. An initial value is the starting value of position of velocity. It is used to solve for a particular solution to a given differential equation. So basically, to determine Newton's law of heating and cooling, you have to do the derivative is equal to k t minus ta. So what you have to do is you have to get the factors on the same side as each other. So you do dt over t minus tu equals k dt, and then you take the integral of both sides, and then you finally end with the function for Newton's law of heating and cooling. Okay, a real-world example is determining time of death. In crime scenes, the police often have to determine the time of death of the victim, and they can look at the given body temperature of the human when it was alive, and they can look at the current body temperature of it now, and they can determine the temperature or the time of death based on these two temperatures. They also have to factor in cooling rate and the temperature of the environment it's in. This determination is done with Newton's law of cooling. A career that uses Newton's law of heating and cooling is design manufacturing, working on appliances. A design manufacturer creates efficient and effective products for consumer use. For example, this can be like creating appliances. And for example, they can design a refrigerator to cool down food to a certain degree. They would need to use Newton's law of cooling to establish the amount of time needed for effective cooling. Thank you for watching my presentation.